On a Saturday afternoon, 3 separate family groups visit their local cinema to watch a feature movie. The cinema names this as Dollar Day, where the ticket prices for adults, children, and pensioners are charged in whole dollar amounts. This fact is going to become important later in this solution. Whole dollar amounts, therefore, the answers to any problems in terms of the prices must be integer. The table below indicates the number of people in each category and the total paid for each family group. So we can see that Group 1 consists of 2 adults, 4 children, no pensioners. Group 2 consists of 3 adults, 6 children, no pensioners. And Group 3 consists of 2 adults, 5 children, and 2 pensioners. And we're going to let A be the price for each adult, C the price for a child, and P the price for a pensioner. Formulate the equations that can be used to determine the ticket prices. So using Group 1, we can see that 2 adults plus 4 children is equal to 108. Let's call that equation 1. Using Group 2, we have 3A and 6C is equal to 162. Let's call that 2. And using Group 3, we get 2A plus 5C plus 2P is equal to 152. Using the equations formed, determine the total cost for a group consisting of 1 child accompanied by 2 pensioners. If we just do equation 3, take away equation 1, 2a take away 2a is 0, 5c take away 4c is c, and 2p take away no p's is of course 2p. So 3 take away 1 gives us c plus 2p, which is exactly what we want in the question, and that is going to end up being 152 take away 108, which gives us 44. So it would be $44. We're now asked to solve simultaneously the equations formulated in Part A. Now note it's just 2 marks, which means that we could do it on the CAS. So if we go to keyboard and get the simultaneous equation solver, on Math 2, if we press this one, we get the extra equation. And I'm just going to call AX, C, Y, and PZ for the purposes of doing this. So 2x add 4y is equal to 108. And then we get 3x plus 6y is equal to 162. And then finally, I've got 2x plus 5y plus 2z is equal to 152. And I need to tell the calculator I'm solving for x, y, and z. And then we get this. So I've got A is equal to 4p minus 34. And C is equal to negative 2p plus 44, with p being equal to p. Now that's a single variable parameter, which suggests that we probably get a line of solutions, but we'll look at that in the next part, which says explain the geometric interpretation of the equations and the simultaneous solution. I'm just going to go back up here for a moment. And if I take equation 1 and divide it by 2, I get a plus 2c is equal to 54. If I take equation 2 and divide it by 3, I also get a plus 2c equals 54. So that is 1 and 2 are the same plane. And therefore, and obviously I should state it in this area here, but we've got the coincident plane like that with a third plane coming across, and we get a line of solutions where 3 intersects 1 and 2. We're now going to assume that the price for an adult is greater than the price for a child, and that the price for a pensioner is the lowest price ticket. So what we're saying here is that A is greater than C is greater than P. We want to determine the ticket prices for adults, children, and pensioners on dollar day. So if we go back up to here, we're going to need 4p minus 34 to be positive and negative 2p plus 44 to be positive in order for this to all make sense. So 4p minus 34 is greater than 0. So 4p is more than 34, giving me that p is more than 8.5. Negative 2p add 44 is greater than 0, gives me that 2p is less than 44, and therefore p is less than 22. Now remember that p has to be an integer value. So what that's saying is that p needs to be between 9 and 21. So we have a number of possibilities to investigate, but remember, we're after one where this is the case. So I think that we can do this nicely in graph and table. And I already have the functions in here. I've got the 4x minus 34, which is the adult ticket, and the 44 minus 2x, which is the child ticket. Let's select both of those and produce a table of values. I've already set up my table so that it starts with p is 9. Now remember, we have to have a more than C, which here it isn't. If you look at the top here, the A is 2 and the P is 9. And over here, the C is 26. Now, if you actually investigate this table, you'll find that the only one that actually fits is when P is 14. And that's the adult price being 22, the child 16, and the pensioner 14. That is the only one where the adult price is more than the child price is more than the pensioner price. So we have that the adult price is equal to $22. The child price is equal to $16. And the pensioner price is $14.